Thank you again for being here. And now it's time for the second part of the second session. Again, services for advanced energy efficiency. Now, Christian Pozza, that is from EURAC, the coordinator of the Moderate project, is going to give us the presentation entitled Leveraging Shared Knowledge to Boost Data-Driven Workflows. So the floor is yours. Thank you. I give you also the mic.
So thank you. As you can see from the title, I will focus not directly on data-driven services, but more on how to bridge some gaps that we find relevant in the Moderate project, which is how to make available and viable the connection with data to organization workflows, so to be able to share data in order to feed some services, even third-party services, and to remove this type of barriers. So the drivers for us, for Moderate project, has been the consideration that there are some needs from data collection to standardization. We saw a presentation by my colleague Daniele previously. Then there is still the need to get complete and trust high quality data sets on buildings and energy, and then reliable data-driven services. We know we presented a lot of different advanced data-driven services, but in the end, the problem is to get data and to manipulate correctly data in order to take all the benefits from these services. And then, again, also interoperability. As mentioned, there are a lot of good services out there, also here today, but still barriers are in how to properly share data with these services and how to integrate these services into organizational workflows. So the Moderate approach is basically a collaborative approach. We first define a software pipeline, including everything from data collection, quality, standardization. We go through synthesization of datasets and enrichment of data that we collect and manipulate. And then we feed, and we also produce data-driven services, which are interoperable by nature, because we think at them from the beginning in this way. And all this is a software pipeline, which is basically all open source and available for everyone in different ways. So we validate this inside the project in real case studies with real industry. And we make these pipelines adoptable by new stakeholders, so that we think at them, we produce them, so that thinking at the end goal of being integrated at some point with, in some ways, in the different workflows by these organizations, keeping in mind that they have probably slightly different business that we focus initially, different assets and different needs. And then the fourth step is that we produce a platform, a marketplace, that has all the instruments to interact and approach these services, also from developers' point of view, but also from non-experts' point of view, so the end user, which can get confidence around machine learning, AI, data, and everything, without needing from the beginning to hire a developer. Okay, so we share almost everything openly through codes, open datasets, or open APIs in certain cases. And we also, as a project, we promote a cooperation with other projects, with other stakeholders, with organizations, institutions as well, in order to enable them to replicate our results, to adopt some of the codes or maybe to push their services on and showcase them, and maybe make them interoperable in the same way as we are doing. So, about sharing data with services, we work. Well, we first identify that in many situations there are the first barrier is, okay, I have to share data. It's an essential step. Without sharing data, I can't do anything with a data-driven service. It seems obvious, but it's blocking a lot of companies in doing everything. Even inside the company, well, if one doesn't look at that, it's not a problem, but some companies, many companies, face the need to share also within the different branches certain type of information, for example, with marketing. And then obviously with external developers. Technology is changing daily, more or less. It's very hard for small and medium-sized companies to have in-house this development. And so they would go for external, for outsourcing. And this means that you have to share some datasets at some point. So to do that, in energy and building, we provide certain solution. We are not the first in class. We are not the first to do that. But there are not so many solutions out there that are also open source and reliable to do these things. Because confidentiality issues are still a barrier, and it's not so easy. We go through data synthesization approach. It provides scalability, bias reduction. It provides more various and high volume datasets, starting from own datasets. It has other advantages like cost savings. It can enhance, we will see later, enhance the performance of training machine learning models and the consequent application of machine learning models. It can also integrate well with real datasets, improve on time also, I didn't mention here, and it is a robust solution for coping with data protection and privacy issues concerning big data. So it's not an anonymization, which basically doesn't scale up, but it's something like that which fits better with big data approach and then the analytics. And then there are other advantages. There are also some disadvantages, sorry. The first that I can mention are that someone to do that should have skills to put there some effort and also time. And the result should also be handled properly. But in principle, what we do is that, and it's also to provide a pipeline for that to all of you, is to train machine learning models using different generative algorithms like GAN or conditional diffusion model. And the pipeline also validate at some point these models in order to give you a sort of quality index or some estimation on how you can rely on the results of trained models. And what is the result of this model? Trained model it is that you can generate a complete, coherent, high-quality synthetic dataset. And this synthetic dataset contains more or less a good representation, but without many of the confidentiality issues of the original data. That represents altogether the energy behavior of a building, for example, or a system, the indoor environmental quality like comfort, temperature, conditions, and other relevant parameters altogether. And you can replicate every time a different output from that. So then the number of cases or data sets that you can obtain from that is very high. It can be static, or dynamic data. So it can be, for example, energy performance of buildings, which are static data, or over an area, for example, or dynamic data like time series of temperatures or other things. Not as a single time series, but as a full set of time series concerning a type of building or a specific building in a season or whatever, latitude and so on, and a different level of aggregation. This is an example coming from the application of adversarial network. On top you can see the original data. On the other graph at the bottom you can see that there are similarities, so it is well representing the curves on top, but you cannot identify specific patterns that are only present in the original data. So for example, if one opened the door at a certain point or during the day, this behavior is not reflected into the synthetic dataset in this case. And it means that the confidentiality issues is solved, but most utility of the dataset, of the original dataset, is preserved. And you can use the synthetic data and even share the synthetic data to a community, which is the purpose also of Moderate. This is another algorithm. It's a different one. It works on images instead of time series data, but the principle is more or less the same. You get a synthetic version of what is of the model of the dataset coming from a model which is trained on the original dataset, but you get something which is not so problematic. You can only store the model, for example, and not the original data, which is also a very big advantage in the next time, and so on. So what we provide is an adaptation and testing and all the pipeline of these generative methods applied to energy and building dataset. So now, can we make an on-demand generator, like a service that you ask for having certain dataset or certain type and have back the full dataset with that characteristics? Well, this is probably in the future one could do that, but to do a fully automatic service for doing that is not feasible now, I'd say. Because the generation, the process, and everything, that stuff I mentioned strongly depends on input data and also on the purpose that you, on the reason why you are going to produce synthetic datasets and the use of that in the future. So it depends. There is not a standard way to do that. It depends on the purpose and the input. And also, it's important that someone check that the information is not the information that you can get from the synthetic dataset that is still containing some issues, like again in the confidentiality issues, privacy related. So does it make sense to do that? Yes, it makes sense to do a synthetic dataset until it is useful and it doesn't contain confidentiality issues. This is more or less the thing. But if you reach to do that, and you could do that using directly moderate pipelines and seeing what happens on the platform, but also you can take all the codes and do it yourself with our assistance or not. Okay, it's up to you. This is something that I encourage all of you to explore and to keep in touch with us in doing that. Because there are a lot of, running out of time, but there are a lot of positive effects also in the services. And this is also the reason why we push a lot on synthetic datasets, because you can improve the performance of the services that you can base on the datasets. For example, in this case, there was the problem of identifying in a better way, in a more reliable way, which buildings within a dataset, any dataset, which buildings have better performance. The point is there are very few items in any dataset which are buildings having high performance. So it's very important to train any model, for machine learning model, with synthetic datasets which are not underrepresenting the buildings which have high performance, because if you do that, the service will not work in a good way. Maybe it can work, but not at best. So what you should do before is to generate a synthetic dataset. We have a dataset of over 1 million synthetic EPCs from a region, and but you can also do it in another region, having some datasets. And then on top of that, you can experience also by yourself that certain services like this one, which is one of the services offered by Moderate, will improve the performance. I'm running a bit late in time, but this is another example. For example, we have a service that evaluates the quality of energy performance certificates. It's a huge problem. I don't know if some of you, I think yes, you had some connection with energy agencies and so on. EPCs are collected, and the quality of EPCs is usually very low. They get filtered and everything. But in the end, still a lot of artifacts or defects that might be inside the EPCs are still there. They go into statistics and creates a lot of issues. So to make a model that can identify if the quality of EPCs is high or low and where is the problem, can be done much better if you produce a synthetic dataset starting from the original dataset, and in the synthetic dataset you add certain characteristics in order to populate it correctly, for example. Quickly, Moderate has approximately 10 services of any type, from detection of faults, forecasting. We have a tool that plans renovation of buildings, something related to solar, PV, and the assessment of areas of potential benefits from establishing energy communities, knowing characteristics of building stock there, measurement and verification tool, benchmarking, and others. But you will find them, most of them as open code. Most of them are already on our GitHub. But what I wanted to point is that we can also host other services from all the other projects, as long as they are a Docker image. For example, we already did it with a couple of services coming from outside our project. I will not go into detail on how they work, but just to point you to the fact that they benefit from being on the Moderate platform, because they can integrate more knowledge coming from synthetic datasets that are already on the platform, which are also open. So, for example, this energy benchmarking service has been developed by Politecnico di Torino. They dynamically identify set of buildings with similar characteristics on time series data over a dataset. Relying on synthetic datasets strongly improve the capability of recognizing the right groups of buildings. So this has been already put on our platform, and connect to the data sources. The same for this, fault detection. It strongly rely on existing or data sets. And about, I'm closing, just to bring you the focus on the marketplace. There will be a marketplace launched in a couple of months, where you can find all the open data sets, services, and software pipelines. You can also push your own, so just contact me or my colleague Daniele for that. There will be a programming environment, also interactive, where you can simply change some codes and it runs again on the platform immediately as a playground, and also a more advanced service for supporting companies in a test before invest approach. Please visit our communities on GitHub and Zenodo. We want to cooperate also with other projects. If you also have data sets, we can provide you the instruments to make it synthetic, and then we can check it together, so don't hesitate. We don't want to steal anything to anyone, but so everything will be on your side, but it's very important that we all benefit from this type of investment from the community and the partners. Thank you. Sorry for...
Christian, thank you very much. Now we have other two presentations. Jose, again back, this time representing DigiBUILD. So the floor is yours. District heating energy management system for smart building energy use. Okay, great.
Okay, thank you again for introduction. So, hello again. So basically, what I'm going to explain right now is one of the services that we have in DigiBUILD, just focus on the district heating network that we are working on in Spain, and some digital twin that we are using for better informed decision making in this case, with recommendations for the facility manager. So here I would like to thank again as well Veolia, as it is the provider of the district heating network. So they are working with us and providing the input data and so on. So thanks to Veolia in this case, that is a partner of the DigiBUILD as well. Basically, I will go through a background of the project, that even though Dimitrios in the previous session introduced a bit, I will go more technical in introduction. I will prepare something about the digital twin, how we define the digital twin in this approach, the application case, just to let you know how it is, and the preliminary results that we have already in the project. So basically, as said before, one of the things that DigiBUILD is working on is about the contribution for energy efficient data spaces, the building data spaces. So that's why we have some data that is being collected. So here you can see the image I will explain in a bit, using co-creation methodologies following the Bauhaus initiative, and also we have talked in the first part of the session about the gathering of the data and using the data properly in a adaptable way, not only from the time series data, but also considering the data models that Dimitrios presented in this first session. So basically, the approach that we have in the DigiBUILD, we have 9 pilots and 10 use cases. We have the users also as core of our approach, and all these pilots and use cases are providing data from electrical vehicles, data from thermal information, data from the users, data from very diverse data. And this data can classify in 3 ways. First of all, dynamic data, what we said, time series data. That is the operational data that we have according to the building operation or electric vehicle operation. The static data in form of knowledge graphs that was presented at the beginning of this session. So this is the second one. And external data that could be whether climate services, could be other data spaces services, other inputs that are external for all the pilots, but they are surrounding our approach. Thanks to these repositories, we have the layer of business intelligence in form of data marts that our colleagues from NTUA are working on it. So it's focused on different businesses of the buildings, like thermal energy, SRI, and this kind of aspects, in order to provide not the whole raw data for the services, but just providing the data that is needed in an aggregated way, let's say pre-analytic data, that could be shared for the services, and then the services could be more pragmatic, not filtering data, not transforming data, but data is already filtered, transformed, and clean. So this is the objective of the business intelligence, and we have later on the analytics, AI-based analytics, digital twins, that is the service that I am going to present, digital logbooks, other services, and so on. So basically, this is our approach in DigiBuild. Let me change a bit for what is the real context in Europe right now. So Sofia before also presented the outcomes that have the European Commission about the building stock and the inefficiencies. So we are currently in the renovation wave strategy from the European Commission, and the district heating plays a very important role in Europe. So we have many district heatings around Europe, mostly in Central Europe. It's true that in Spain there is no very common. It's been more common nowadays, but it's not quite common. But yes, in Central Europe, in cold climates. And we need to optimize this district heating network. Sometimes they are using energy for covering the demand, but they are let's say overestimating the demand that they have. So that's why the optimization techniques are very useful. Within the current approaches that are in the literature, we can see that these are the data is treated as isolated silos. So we don't have the full approach within the district heating network. They are using some functions that are weighted, so they are not like considering the full district heating network as a whole, or using mathematical formulation that should be simplified because the physics are complex in these systems, and also using very complex artificial intelligence algorithms. And here we should say that it's a user-centric approach, so it should not be complex to understand for the end users. In our approach, it's a gray box approach where we mix the physics from a model I will present later with the data. So we have a mixture of both things in order to simplify the problem. In this case, we have a simplified hybrid data-driven model that I will present later, reducing the computational load, not only because of the data marts that I presented before, but also we don't need all the data set to run the optimization techniques. We are using partially one model. In this sense, the definition that we are using for the digital twin is the one took from IBM. We should consider, I highlighted some keywords, so it's a virtual representation of the physics that we have in the physical world, but should be updated in real time. So we are updating the information in real time, and is used for simulation, machine learning, and reasoning to make decisions. So just we are, as mentioned before, taking decisions according to the recommendation that the optimization techniques are providing. In this sense, this is a link between the physical system and digital twin, and according to this reference, is to that in DigiBuild we use a different level approach, but taking this reference just for the whole public, we are in the level of intelligent digital twin. We have advanced analysis and professional analysis as we count on BuildON in this case into account, and their feedback, their usability, and so on. So within the levels, we are achieving the intelligent digital twin, not only connected, but also intelligent. It's true that we are not performing any control because we don't have the permission to control systems, but our control, let's say, is manual, provided by the operator of the network. Thanks to these digital twins, we can simulate different scenarios with different conditions, with different parameters that the user can provide. So it depends on the users if these parameters are okay or are parameters that are above of the scope. We can optimize the operation of the district heating according to the different conditions, different scenarios, different simulations that we perform, but also using the operational data that we have in real time from the system. Of course, something that is important, it's true that the district heating operators have some SCADAs to see the information, to visualize the real-time information and how the systems are performing in real time, but not about the trends, the historical data. They should download the data, then use Excel or this kind of sheets in order to, or these tools to visualize this information. So not only the current status of the network, but also the simulation parameters, the historical data, and combine everything and use also prediction services to know what will happen in the future. So we're combining a lot of information to visualize and to provide this information to the facility manager, in this case, Veolia. And of course, as I mentioned before, with historical data, understand the behavioral patterns. We know that the users, in the district heating, we have many, many users. In this case, I don't remember exactly, but 500 dwellings, if I remember well. So you can imagine everyone has its own feeling, its own comfort parameter, and the behavior pattern would change from user to user. So then aggregating by building, so we will have different patterns of behavior of the users. And of course, as I mentioned before, forecasting services. In this sense, our approach is like the schema I'm presenting here. So we have like the left part of the schema where we can see our physics of the system. So is the district heating information model that you can see on the left part of the schema. So I don't know where is the mouse, but anyway, the HIM part. This our model is based on CTGML. So with this, we are able to model the thermal parameters of the network. So we are not going for a CTGML model very, very complex and very, very complete. So just the level of detail that we need for the simulation of the operational data. And on the other hand, we have the SCADA, the time series data that provides us the real-time operation of the system. Both data should be synchronized because the same element that is in the model should be the same element that we are measuring in operational data, so otherwise we will be lost. As I mentioned before, the data mart is combining this information from the two resources, as I presented in the architecture of DigiBUILD, and we are using a Python library in order to simulate this network. The simulation is taking into consideration the user, of course, the user parameters, in order to determine the thermal losses that we will have in the network if we run the network according to the conditions that in this case, Veolia is providing. So with this, we will be able to predict how many thermal losses we will have in the distribution network. That sometimes the distribution networks are neglected. We say that, okay, we don't have losses in the thermal network, and this is not true at all. So we should consider these losses. And on the other hand, we have the services. On one hand, we have the production forecast, that is not only production, it's also demand. So with this, we estimate the demand from the buildings thanks to machine learning methods, and we're able to know the thermal demand that the buildings will have. So we have the real total demand of the district heating will be the demand of the buildings plus the thermal losses that we will have in the network. And in this case, they have a power-to-heat system that is based on photovoltaic system, and we are able to predict as well the amount of renewable energy that will be provided in the system. So we have to subtract this information or this data from the real demand. In this case, this is the information that is entering in the performance optimization algorithm that performs some kind of algorithms in order to recommend the operations of the district heating. There are two kind of outputs. First of all is the inlet temperature to be used in the boilers. So we are reducing, I can anticipate that we are reducing approximately 5 degrees of the current set point that they are using in the district heating network. So they are using 87 not exactly 87, but it's very constant, the set point. So we are reducing, in average, 5 degrees currently in the initial simulations. And also we are approaching a load balancing of the boilers. They are using 3 boilers, and we are balancing the boilers, the usability of the boilers, increasing also the life cycle of these boilers. So these are the two outputs that we are in this approach. Now about where this is applied. So it is in Spain. You can see that it's Valladolid. It's in the north of Madrid, so in the middle of Spain, more or less. This is the neighborhood that we are counting on, and just to zoom in the neighborhood, we have a set of buildings that are around the neighborhood with a big tower that is in this neighborhood, and this tower has photovoltaics integrated in the facade. So this is the one that is providing the power-to-heat system to the network. Basically, the network consists in a set of buildings that are, as I mentioned before, with 3 boilers. 2 of them are biomass-based, and the third one is for supporting in a gas-fired biomass boiler. The district heating network is providing the thermal net, or covering the thermal demand for the buildings, and we have the photovoltaic system that I told you just in the previous slide in the tower, and of course the electricity part of the system. The district heating is composed of 3 different circuits, with the connection that you can see in the schema of the right side of the presentation. So we have 20 buildings, 1 tower and 19 blocks with thermal storage. This is something that I summarized just before about the distribution of the network, just to let you know how the network is configured. And here you can see the CTGML model that was created for the network. This is the how it looks like. So we created this CTGML network with the different pipes, the different systems that they have. It's true that we are currently updating this CTGML model that is already finished, but it was not finished when I prepared the slide. But the CTGML is containing all these physical parameters or all these physical properties that we need to simulate the system. So with this simulation, as I mentioned before, you can see the different results that we have currently in the network. So this is a simulation. Maybe the numbers doesn't make sense. So just to let you know that it works. Because in this case, the user can provide some parameters like comfort set points for the different buildings. They can provide a set point that they can use in the scenario. They can provide also the prices for the fuel. So there are some parameters that maybe doesn't make sense that when we simulate and we test different scenarios. So don't take into consideration the results, just to know that we are knowing the heat losses that we have in the network, also pressure losses. And we have some information about the temperatures. So this information is the input that optimizer is used. And with this information, we also have the optimization part, the decision-making part, and with this I'm concluding, basically. We have the energy consumption, the heating degree days of the network. With this, we created like a model, a linear regression model at the current state, but this is being improved with different models in order to improve the accuracy, because we know this linear regression model was fitting in the data that we have in the correlation between the energy and the heating degree days, but we are going to improve this part. But also we know that from physics, we know that the delta temperature and the flow is also a formula that can provide us the energy that is being consumed. So we have the machine learning module and we have the physics on the other hand. And with this, we also know that the distribution system depends, they have some thermal losses depending on the temperature of the ground. So thanks to this, as I anticipated before, the original set point for the simulations were 87 degrees, and we are now approximately in 81.43 degrees, so reducing the inlet temperature, so reducing the delta temperature of the system, then reducing the energy. And we are saving in the initial simulations, this is simulated based, 88 megawatts hour. So considering that we have a yearly consumption of 1.6 gigawatt hour, we are approximately in a 5% of potential energy savings, and that we can achieve. Of course, we are now deploying these models within the real environment. We need the BuildON in this case to use the tool in order to apply the new set points, and we will see if this is even higher. We expect that it will be even higher than the current numbers. And just to conclude, that we are using this digital twin in order to optimize the energy resources that we have in the digital twins. And we are approaching not only artificial intelligence, but also combining with physics, as I presented during all the slides. And of course, this provides some potential for improvement in energy management, because this is a powerful tool for the facility manager in order to take decisions according in data. But just to finalize, it's important that we need to digitalize the systems. If we don't have data, of course, we cannot provide this kind of services, and users must be the core of our approach. And yeah, that's all from my side.
Thank you. Thank you, Jose. So it's a sort of marathon, Now we have another presentation from N2A. Statis is going to present the work done not only in DEDALUS but also in DigiBUILD. So it's basically a combination of the two achievements. So Statis, the floor is yours.
First of all, thank you very much for all these interesting presentations. Okay, so now we're going to discuss about the AI-based services and even non-AI-based services within DEDALUS and DigiBUILD. So let's have a broader scope of the challenges that we face and regarding the topic. So one is the main goal nowadays, the energy transition, and to transition from the fossil fuels to the renewable energy sources. This will make our systems more sustainable, and in order to achieve that, we have to develop methodologies and services that are able to consume the vast amount of data that buildings generate in order to better manage the energy usage within buildings. So the technological role of AI is that it can act as an enabler in this transition and provide all the optimization techniques required for the better energy use within buildings. This overall can reduce and the greenhouse gas emissions of the buildings. So let's get to the challenge that EU places, and through the updated, through the revised EPPD. The previous years, from the previous EPPD, the goal was to reduce the energy demand. The current EPPD says that we not only reduce the energy demand, but achieve carbon-free buildings during the operation phase of the buildings. In order to do that, we have to implement demand response algorithms and to utilize the energy flexibility different buildings offer. In order to do that, smart building solutions need to be developed. And here are DEDALUS and DigiBUILD. In the context of DEDALUS, we are trying to identify the possible flexibility of buildings, either electrical or thermal, and apply proper demand response solutions and demand response solutions, either at building level, at district level, at virtual cluster of buildings, or cross-commodity scenarios. On the other hand, in DigiBUILD, it's not a so active solution, we can say. We are trying to provide recommendations to the users, residential and non-residential, through AI-based services that are mainly either act as an API or standalone tools for the energy profiling of the buildings, the energy forecasting, the resource management, the enhanced comfort and well-being of the occupants of the buildings, possible renovation roadmaps that can enhance their energy efficiency, and something different from the above mentioned, the climate resilience of buildings. But let's dive deeper to the DEDALUS topic and what we developed within the DEDALUS. What is the issue? The issue is that in order to provide demand response events, we have to have disaggregated data in order to identify which is the flexibility of the buildings and quantify it. The solution is to try to model the disaggregated data and different devices in order to be able to then disaggregate aggregated data without having the devices and without having the detailed measurement of the different loads within a building. And of course, generate demand response events to the users. So the first approach is, first of all, to identify the flexibility within a building. In order to do that, we designed a specific methodology that is based on an energy prediction model that at its core has an LSTM model, then where we can predict, which enables us to predict the energy consumption of the building and the different loads of the building. We defined a flexibility methodology where we can assess how flexible a building is. And of course, we have to identify which is the baseline in order to compare how flexible a building is. We have a specific demo site in Austria, in Wiener Neustadt, if I'm spelling it correctly. Yeah. And the building consists of 2 floors. For each floor, there is a dedicated photovoltaic systems supplying electricity. The data that we used is the energy consumption data of the building and the PV production of the building. And the duration of the data was 2 years. So first of all, we analyzed the weekday data for the building. And of course, we analyzed how the different weekday, how differently the user operates at a different weekday, the different day of the week. Then, based on this pattern, we calculated the baseline calculation, which is the mean operation of the user during a certain day of the week, the maximum and the minimum of its operation. And in order to calculate the flexibility levels, I will get more in detail later, but let's say that we subtract the actual energy from the baseline consumption, and we generated a metric, which we'll dive in now. This is the energy flexibility indicator, where we calculate the maximum. Okay, let's not dive deeper to the mathematics of the problem. We can generally say that we are classifying the flexibility of the building in 4 classes: A, B, C, and D. A is the most flexible one, and as we go down to D, the less flexible. So this way, we are able, when we generate a new prediction from our model, to classify the result based and identify the flexibility of its energy. And to put it in a more concrete tool, we developed a flexibility assessment tool where we can firstly select the country that we want to calculate the flexibility. Okay, I skipped some steps over here. We select the model, we insert the data, we select the time range of the flexibility. Okay, this is some data analytics, and then we calculated the flexibility. So, as you can see on the upper chart, the range between the mean and the not the shaded, okay, we can say the shaded area is the flexibility a load can offer. And where can this be used? Another step is another task within the project is the non-intrusive load monitoring. This is what I said before, is to model the devices and from aggregate data finally have some disaggregated data. And try to place them betterly across the flexible hours of the day that identified before. Yeah, so both these tools can operate together in order to better utilize the flexibility of a building, which is actually the energy production from the photovoltaics, and reduce the overall greenhouse gas emission of the building. Now we'll move on to DigiBUILD. Partners from the project has already given some details about the project. What I want to highlight is that we have several users within this project with several needs. What are the roles? What is the role of DigiBUILD services within the DigiBUILD ecosystem now? First of all, we design the services based on the user needs. Later on, we collected the data. We make sure that the quality of data is high, or if it's not, Cardiff, who was responsible for this, developed the required methodologies to enhance the quality of data. The data got semantically enriched, and then they were shared to the data-driven services, which are actually the consumers of this data, in order to generate insights and recommendations to the users. These recommendations can be shown to the users either through web tools or through the digital twins. First cluster of services within DigiBUILD are the AI-based services for finer-grained energy profiling and forecasting. Here we wanted to either forecast the building demand, the demand of a building, to better to make the monitoring and the benchmarking of the building smarter, and of course forecast the renewable energy sources of a building or an off-site photovoltaic. In order to do that, we developed machine learning algorithms, neural networks, or even used transfer learning techniques or incremental learning for achieving better results. To give you a specific example, we developed a model that can be applied to complex buildings. Here I will demonstrate you the machine learning model we developed for the FVH pilot from Virium Helsinki, which operates a building of 3 sectors and 7 floors. So we understand that there are many different rooms within this building. So it would be difficult to have one model that can predict all of them at once, or what is required, what we want to predict, or we would need different models to perform, let's say, sector-based forecasting, or floor-based forecasting, or room-level forecasting. What we developed was a custom MLP neural network with hierarchical level segmentation that is able to handle, say, regular time series data effectively. This seemed to be adaptable to dynamic environments and easy to apply to other buildings and easy to train, and of course be compatible with other entities within DigiBUILD, like semantics, so it is easier to train a new model without knowing the new building, the specific metadata of a new building. The advantages of this model is that It has a great balance between accuracy and efficiency in training time and scenarios, since we only have to train one model. And it can give, since you have only one model, it's easier either to integrate it or to give, to provide instance to the end user based on his needs, either to forecast all the building or specific room or a whole floor area. Now, another tool is under this class of tools is the energy efficiency and HVAC units replacement in office buildings. A request from the users is to benchmark how efficient multiple HVAC units operate within a certain building and try to identify which are the best to replace. In order to do that, we modeled each individual device based on historical data, and based on the budget of the user and the ability to heat or cool of the new equipment, we calculated the best payback period of and in which room the heating and cooling equipment should be replaced. Also, we took into consideration the comfort aspects of the room. So if the new device can still heat or cool the place at an acceptable levels. So another cluster of services are the data-driven services for energy resources management. These are mostly related to managing energy networks, like district heating network that Jose mentioned before, or other microgrids that contain, as you can see in the image, might contain a building, battery maybe, interaction with the grid, and energy production. A particular example that we developed here is that we wanted the user to be able to understand, not understand, to make the user, the consumer, the energy consumer, actually a prosumer, to try to make him understand how carbon intense his building is, or his, in this particular example, his EV charging is. Because, okay, we are talking about that combustion engine are carbon intense, but also EV, electrical vehicles are also carbon intense, and the carbon intensity is based on the energy mix of the grid, but also on the production of the building. There are several methodologies that have, let's say, that they are trying to utilize, to better utilize the produced energy from an on-site PV or an off-site PV. But there aren't many methodologies that can help the user consume energy based on the energy mix. So what we did here, we developed a methodology where we can understand the carbon footprint of the energy mix, but also in collaboration with the energy the user will consume and the energy he might produce if a renewable energy source is available. This way we can identify which are the most carbon intense, subjectively more carbon intense hours of the day. And based on that, to generate a recommendation system where to place his flexible loads across the day. And of course, what we also did is not only connected with the digital twin, but also we are able to send and actually who is the user of the digital twin is the facility manager, where he can operate, let's say, a cluster of buildings. But through DigiBUILD, we were able to connect with an application that the pilot operates, that every user has access, and we can send direct recommendations to the users. Last but not least, something pretty different than we discussed before is the decision-making under uncertainty tools for efficient climate-resilient buildings. Here we wanted to develop a tool that can help us evaluate how climate resilient a building is. And so, what is the climate resilience? Climate resilience is the ability of a building to withstand certain climate hazards. And of course, do all that in an intuitive web-based tool. So what are the steps we follow in order to calculate the climate resilience of a building? First of all, we have to identify which is the exposure of a building to certain climate hazards. These hazards are the heat waves, cold waves, heavy precipitation, flooding, storm, and drought. We didn't decide which are the climate hazards. There are certain directives and from EU shaping the priority of the climate hazards. So these are that we used. With the only difference that instead of subsidence, which is difficult to calculate based on the data available, we used cold waves, which is a secondary climate hazard. So we replaced subsidence with cold waves. So first of all, based on where the data exists in place, we create the methodology where we can assess how a building is exposed to these, how much the building is exposed to these hazards. Then we collect information regarding a building and different domains of the different components of the building, like energy systems, building envelope, water systems. Some others dedicated practices might follow, and of course some characteristics regarding the overall topology where the building is. So by defining a certain scoring system, we were able to identify not only the overall climate resilience of a building, but also how resilient it is against certain climate hazards, but also how resilient certain system of the buildings are. Of course, we have published all these reasons in Building and Environment. So, journal, if you want any further details about this tool, you can look for an adaptive climate resilience assessment tool for assessing climate resilience in buildings. Now, what are the key takeaways of DigiBUILD and DEDALUS AI-based services and non-AI-based services? First of all,
It's back.
okay. First of all, it can help users to optimize their energy use, cut costs, and enhance their overall sustainability. Then, through integrating these services with the digital twins, we can offer smart building solutions and, of course, improve the flexibility. And in some cases, where the user takes action against the recommendation, against the recommendations, either perform better or increase the resilience, or even occupant comfort, which is, let's say, one of the key aspects of DigiBUILD. So with these two projects, we leveraged the AI to tackle the major energy challenges that EU sets for the buildings. And of course, we hope for market uptaking these innovations in order to achieve the overall goals of the building stock. Regarding the future impact, of course, the scaling is something that we all had in mind when we developed services, as of course interoperability, and in order to be able to large scale and revolutionize the energy management in buildings and to lead to more resilient and adaptive buildings, we have to extend the use of them and how they interoperate with other services in this environment. Of course, as we all know, without regulations and policy making, we cannot move forward into engaging even more people in this, with these solutions. So thank you all for your attendance.
Thank you. Thank you very much. We can forgive you since you have 2 projects and 2A is really leading partners in the development of AI-based, machine learning-based data-driven services. So they are doing a relevant amount of work in both projects. So their contribution is quite consistent. So I cannot stop you talking. So even though we are in delay, we have 20 minutes. So it's time for the panel. I would like to invite all the speakers to stay here. I think that it could be a good idea. So we can leave the floor to the audience. I suppose that some of you already took note of the questions that you want to ask to our speakers. So I think I can take the mic and this is the mic. Okay. So thanks again to all the speakers that provided us an overview of the huge amount of work that they are doing and the projects that promoted as a workshop. So I want to ask to the audience, I suppose that people that are here are really, really interested because it's quite late, so people are leaving. And I want to ask if you have questions that you want to ask to our speakers. If not, I can ask something that I already have in mind. Okay, this is a self question, and this is a load. Is in the regulation of the conference. You can ask a question to yourself and answer the question by yourself. Okay, I don't know if you need the mic. Yeah, I suppose. Okay.
Well, first of all, thank you for all the interesting presentations. Actually, my question is about the BIM-based solution that we saw during this session. And I saw that both of you, that you develop ontologies and data modeling, try to data model the buildings, you use the brick schema. And my question is there a certain directive from EU to, or recommendation to use this schema? Is there any other schema that they recommend? Or this is based on your, let's say, how can I, or preferences?
Okay. So the answer is that the schema is important for the implementation, but not so important which one you choose. You choose the one which is more relevant for what it is that suits your information requirements and the problem that you're addressing. So basically, BRIC is in fact not recommended by the EU. The EU is promoting a separate set of standards under the umbrella of SAREF. And potentially we could be using this. So there's quite a few ontologies or data models that support that domain, BRIC being one of them. Asra is developing another one which is quite more elaborate and detailed, and then there is the SAREF group of standards that are being requested quite a lot. In the end, it is what is useful. So a lot of people in practice ended up using Brick because it kind of represents a good balance between verbosity and being useful. And I think kind of that evolutionary process have found quite a lot of people using Brick, and kind of by coincidence we're using that. But really it is a matter of choosing something that is convenient and well aligned with your problem. And Brick has proved to be a quite robust choice for many users that cover the domains that we're talking about.
Yeah, more or less the same opinion. So I started to work with Brick probably 6 or 7 years ago. So when there was the first version, and after now there are several versions already available. And as I said, it's very robust because there is a community that is going to provide all changing something or make updates. And comparing to all the other ontologies that I found out that every year there are new ontology coming from projects, something like this. But my question is also, which is the aim of this ontology after the end of the project? Because there is no one that maintains this ontology, and we have several issues to if there is some problem or something that we want to change, and there is no one that can update the ontology. So there are several. So there SRF, iStack, Brick. But for me in particular, because I'm working on the building domain, this one is the ones that I like a lot. Also for they generally try to cover all the components that characterize the buildings, even if there are a few missing points in particular on the system side. But yeah.
Thank you, Thomas.
You're welcome.
Okay, other questions? Otherwise, I can ask my question. My question is very simple and basic, because I don't want to go in details of what you are doing, because I'm involved in the project. I know more or less what you are doing. Maybe not exactly in details, but I have an idea what you are doing. And but since we are in a place like this, in the very middle of Europe, we have a flag of Europe on our back. I'm thinking about what a European citizen can think about, which are the real effect of the technologies that we are developing on their daily life. So if I look outside, I see very nice buildings. Probably most of them are smart buildings, so I keep it with all the technology that we need. But if I look at my city, I come from Sicily, from Palermo, I cannot see so many smart buildings there, historical buildings, and all over Europe, it's basically the same. There are many historical buildings, many buildings that do not have technology. So my question is, in order to adopt the technology that we are developing in this project, what kind of prerequisite we impose to the buildings in order to get benefits from the technology that we are using? Just to understand how these technologies can be properly adopted by buildings, by building owners, by building energy manager, and so on. So which are the prerequisites to start talking about, okay, you can adopt our technologies?
Well, even though I'm not in the industry, on the research projects, innovation projects, what can I say is that there are different schemes to achieve this. One scheme is that the regulators set certain targets, so the facility managers have to achieve these environmental targets. So they are trying to find solutions in order to achieve it. One way is to use a recommendation system that is tracking, they are tracking their energy uses and so on. Another part is to bypass the user. So to sell a service where it bypasses the user and it optimally operates the system without having the user to have an actual action. But actually the problem is not non-residential users. The problem is the residential users, because they don't have certain goals to achieve. So you have somehow to engage him, and not to engage him through, okay, sit down, I will teach you how to use my tool. We have to make our tools more, let's say, easy to use and easy to understand, and easy to play, let's say, with them, and each user to set his own goals. I don't know if I'm a geek, but for example, if I was measuring my building consumption, yeah, or if I had something that it was easy to understand, and say me, oh, okay, do this action, and you will see how you will reduce your energy consumption. Okay, I might be a prosumer, but this is how we have to, let's say, educate the users and make them prosumers, not through just providing a manual, but making more intuitive the services.
I have to say, I fully agree with you. And this is, I didn't know the social science part before I did this work package, and I found it very interesting to have, to see the end user and to see the willingness of even being a prosumer, actually. And also seeing the willingness of really wanting to know how much energy they are consuming. And so I think if we saw all the personas that were identified in the DEDALUS project, for example, you would really see who would need what to be able to be in the demand response participation, because I think everybody wants to.
Okay, just to complement the answers that they are saying, that it's true that we need to reduce the complexity of this, because we are creating the technology for artificial intelligence, for instance, is there. So we have the tools, we have the libraries, we have everything to do it. We have data already in most of the buildings, and we need to engage the owners. How to engage the owners? Basically reducing the complexity. This is something that they said in my presentation as well, because I imagine a user that, okay, this is doing something and saying to me that I have to put 21 degrees of set point for my thermostat. Okay, but I don't understand what is going behind this algorithm. I need to understand, and I need to feel the confidence of this algorithm is making something that is good for me. And if I don't feel this confidence, this level of confidence of the technology is very, very important for the users. And this is something that the studies mentioned, that the complexity that we have in the technology, and we need to engage the users trying the technology and make it accessible for all, not just for technicians.
Yeah, I agree. You touch also the point of confidence. Maybe I can add on this that, for example, Moderate is not directly targeting the home owner as a final user, or the owner of a building anyway, but maybe more industries that then work in that direction of providing certain technologies or whatever. We think that confidence in technology, specifically in something which is data-driven, implies a step forward in their which is maybe much more organizational than technological for companies. So and then companies will promote their products, their new generation products, to a market. In my opinion, it's not really a question of what to do, because we live in a policy-driven context, and I'd say it's clear that well, when we say we do affordable things, it's okay, but we know it will cost much more than now to build new houses, to put there many products and so on, to change electronics and whatever every 10 years or things like that. So it will have a cost. The point is that the benefit is not evident. and we don't have the possibility to see. I mean, I also come from companies. It's very hard to go there to a boss and tell, okay, I need to change organization of a workflow because I need to get on board certain customers or to deal with data, and for that you need to organize yourself as a company in a totally different way. Yeah, it's very hard to do this step. Moderate, for example, addresses or try to address this point by engaging users and try to show them how things could work and how they could play with these services, in this case, or new technologies, in order to reduce the risk for investing. But in the end, they will need to spend, if it's a company or an owner of a house. So that's more or less my point of view. The confidence, as you mentioned, is very important. It has to be created. And I think the impact of our project is more in creating that confidence step by step than pushing tomorrow a product on the market directly. But this is my personal view. Maybe some officer might think differently, but this is how I think.
Thank you. We have other 5 minutes just to complement this topic, because one of the first sessions I've attended yesterday was about user engagement, and I was listening about the results of their projects, about the engagement. They talked about gaming, they talked about incentives, they talked about awareness and so on. So just to investigate how this is working in our project, we talked about necessary technology, we talked about demand response that involves in some way people, we talked about residential users that had an impact. We are talking about 40% more or less of the energy consumption at the European level. So this means that if they start to save energy, even a small amount of energy saved has a great impact and all over Europe, since it's a huge amount of energy consumption. So the experience that you have in this project about user engagement and barriers to the adoption of these paradigms related to the demand response, the, let's say, deployment of particular devices. I've heard, for instance, a very, very funny thing, because this guy in this project installed some sensors around the house, including the bedroom. And people there asked, but you can deduce who goes into my bedroom? And so you can understand, this is a very strange question. But anyway, I can understand that people can be skeptical about the deployment of devices, but also about the participation to programs like the demand response that don't give you relevant or significant incentive now, but in the context of more complete awareness about the consequences, can involve people to be part of a community. So I don't know if you have comments on this.
In my experience, the most important thing is the knowledge, and that you teach people what this is all about. But for this, you have to gather the people. So this is the first problem, actually. And I saw a very, very strange thing, but a very good thing to keep in my mind, that we were doing a workshop, and we were having a huge room. And I was just thinking, like, oh my God, not that much people will come. But the energy community that was involved in there was somebody who came from that place where we've been. And the room was packed. So this is also something I was just thinking, because there's a lot of prejudice among people, and like to the government and to everything they don't know. But if you have somebody that they know and that they trust, suddenly everybody's here and everybody's interested.
It depends on trust.
Yeah.
Maybe I can pick up. Yeah, I was going to make the same point that what we need to do is we need to develop trust in the technology and kind of highlight the benefits to the users, because the users, they don't care about energy demand, they don't care about set points, they don't care about ontologies, they don't care about machine learning. What they do care is living in spaces that feel comfortable, that don't cost a lot, that provide value and kind of create an environment for families to strive and so on and so forth. So I think we should be working in understanding those needs and using technology to deliver those needs, and then clearly highlighting how that technology is supporting that delivery of the process and building that trust. And I think we've seen from social networks that people are very happy to go out and share all their personal data. And I think this is a mistake that we should not do when it comes to other applications. So we need to communicate that, and we need to develop that and build the trust and highlight the value and help the users understand what the value is. And when they do, I think they will engage and take that on board. And we need to think about the boundary conditions so we can provide that, that path to adoption that will not consider the users as boundary conditions, but will consider users as part of the solution.
Yeah, indeed, the cost is critical, but also the training, because as you said in the bathroom, so I have a similar experience in Valladolid with a guy saying that, no, please don't touch my TV. So you can monitor whatever you want with the exception of my TV. So this was the answer. So imagine that I mean, with this, I would like to highlight that also the training is important in order, because in demand response programs, we need to change the routine of a person. So changing the routine of a person, I usually I do for the laundry on Saturday. So no, but now you have to go on Sunday. But why? Why I need to do? What is the benefit? So training of these benefits is also very, very important. Apart from the cost, of course, this is the most important aspect, the euros that you are saving. But also apart from this, the benefits that you will have having this approach.
Many psychological aspects that
Exactly.
Into account if we talk about people that are involved in these programs. Okay, I think that it's time to close more or less in time. If you have questions, otherwise I take this opportunity to thank all the speakers that are really doing an excellent work in the projects, but also did an excellent work today by explaining what they are doing. So thank you again, and hoping to meet you, of course, in our project, but in other opportunities of the Sustainable Places Conference that is really becoming a reference conference. This morning I was saying that I attended the edition in 2018 for the first time, and I can see the difference. So it's really becoming a very big conference. So thank you again, and have a nice rest of the day.